Okay, so solving systems of quadratic equations. Central question, when you solve a system of quadratic equations, what does your answer mean? Or what does your answer represent? And after we do these notes, we're going to go into the computer lab to give you more time to work on your completing the square. So the homework for this, 3-10 is going to be in the book. So if you are done with completing the square, you can work on the book assignment. But I want to give people computer time if you aren't done with it. So, everyone have a calculator? We're going to need a calculator today. So if you don't have a calculator, come get one. Okay, we're going to go through a handful. One's solved by graphing. Example 1, y equals 2x squared plus 1, and y equals negative 2x plus 5. Okay, get both those written down. I'm going to have to move to the camera really quick. Okay, you have our two equations written down. Solve by graphing means we're going to graph them. So, grab your calculator. How do we graph?
Y equals.
Yep, go to the y equals. I'll put the camera on this screen. Okay. Zoom in. Hit that y equals. Clear out anything that's in there and put in the first equation, which was 2x squared plus 1. The x, as a reminder, is up here by the green alpha button. It says xt, a little 0 with a line through it is called theta, and n. X squared is right here, diagonally up from the 7. Okay? 2x squared plus 1. Now arrow down and put in the other one. Negative 2x plus 5. And you need to make sure both of the equal signs are highlighted. Does everyone have both equal signs highlighted when you type them in? Is there anyone that doesn't? Okay, to make sure we're all graphing on the same window, if you go to zoom, that's this middle button up here. Which one gets you back to a standard window? Negative 10 to positive 10. Yeah, number 6. You can just hit 6 and it will go for you. There's the first one, and here's the second one. So when I'm saying solve, and we have two quadratics, what does that mean to solve when you have a system of quadratics? You have two quadratics. What are we looking for? What? I heard a lady say it. Was it you, Nancy? What did you say? Where they cross each other, where they intersect. So when you solve, your answer is a point, and those points are where they intersect. How many intersections are we going to have here? 2. So we have 2 solutions, because they cross in 2 places. So I'm going to show you on your calculator, which is why everyone should have a calculator. Go get one, please. I'm going to show you, you need a graphing calculator. On your calculator, how to find those intercepts by using the calculator. Okay, also you two. Look above the top row of buttons. Do you see one that says something like calculate? Which one has calculate? Trace. In blue it says calc. So we're going to hit second calc. And we want to find where they intersect. So what option should we pick? Number 5. Okay, and see how you have a little bug? If you go left and right, that bug kind of crawls along your graph. Let's start with the left intersection up here. So arrow your bug as close as possible to that left intersection. Okay? When your bug is as close as possible, you hit enter. It says right here you're on the first curve. Now you hit enter and it changes to the second curve. Make sure your bug is as close as possible to that intersection on the second curve. Sometimes you have to adjust it a little bit. Hit enter again, and then it says guess. As long as your bug is on the intersection, you can press enter for a third time. Are you doing this with your calculator? Yeah. You need to go to y equals and type in both those equations. Okay, did you go to the intersect? Second calc? Okay, and push enter. So essentially we push enter 3 times. What is our intersection? -2, 9. If you could write that on your paper, please. And we have another intersection to do. Harlan, can you remind us how we got to that feature where the calculator will do it? Good. Second trace, number 5. It says intersect. Now my bug is clear up here. I need to arrow it to the right until I get down to the next intersection. And you want to get as close as possible. The calculator says first curve, so I'm on my parabola. I'm guessing all of the rest of you are on that first parabola. Now you hit enter, second curve. Sometimes you can even just push enter where it's at. Sometimes you need to adjust a little bit. So you want to be on as close as possible. Hit enter essentially 2 more times. And our second intersection is what? 1, 3. Okay, so on our notes, let's write down some steps. How did we just do that? And we got our solutions were -2, that was not a 2. My brain is not following me. -2, 9, and 1, 3. How did we find those solutions? What was the first thing we did? We went to y equals, and we graphed. Both of them, not just one. Y equals, and we graph both on the calculator. Once they are both graphed, what function do we go to in the calculator?
Zoom.
Yeah, we make sure our window's good. So check your window. Go to zoom standard. Okay, then what did we do? So second trace or second calc. Second, and then we hit the trace button, and then we selected number 5, which is intersect. Okay, and then we selected the intersection as close as we could. And that's how we got our points. So can I give you one to try? And actually, some of the ones aren't just going to be quadratics on your assignment. Some of them are also linear. So this one's going to have, example 2, we have y equals x squared plus x plus 3. Is that quadratic or linear? That's quadratic because of the x squared. What about this one? Y equals -x. That one's linear because it's x to the first power. So you can do it the same way, though. So go ahead and graph them. Practice yourself using those steps. If you need help, please raise your hand. Oh, interesting. Is this what you got? So, do they ever cross? No. So what do we call that? No solution. You have a question, or was that what you were going to say?
Every time I highlight
Okay. Sometimes if your plots are on, it won't graph. So let me see. Did you actually use the negative sign, or did you use the minus sign? I think you used the minus sign, because when I changed it to the negative sign, it worked. Okay. Oh. Go to. Let's see what the problem is. Oh, you have something weird down here in the hidden functions. So if I clear that out, I think it was just you had something weird typed at the very, very bottom that you couldn't see.
On the first one, it highlighted both of them, but now it won't let me highlight like this.
Yeah, I'm going to reset your calculator because yours is on something I don't want it to be on. Okay, now it should be okay. Alrighty, so that's an example of no solution. Let me give you maybe one more. Okay, on your notes, this one we put no solution since they didn't ever intersect. Ladies in the front. Example 3. Do y equals 3x plus 4 and y equals negative x squared plus 4. Okay, let's practice using that trace feature. Who else had an error in the front? Did you get that worked out? Yeah? Okay. Okay, this one does definitely intersect. How many times does it intersect? Twice. It is possible to only intersect once. Okay, so sometimes you'll have only one solution. Yeah, exactly. It's a tangent line. Okay, is that how yours came out? Okay. So go through the steps twice to find those intersections. Let me see. Your plot's on. If those plots are on, it's not going to graph. Whoa, your calculator really is messed up. Okay, I'm going to reset it, so you'll just have to type everything in again. Okay, should be okay now. Okay, what did you get for the first intersection on the bottom left? Does anyone second negative 3, negative 5? On the bottom left? Yeah? And I haven't done the other one yet. What about on the top right? Yep, so it's kind of dark, but we got 0, 4. Alright, so that's by graphing. Okay, now we're going to do some other types of problems. Actually involve some arithmetic here. So negative 3, negative 5, and 0, 4. Okay, that's solving by graphing. Are there any questions on that? Bryson's on the phone. Sure. Okay, next is solving using elimination. Solving using elimination. Example 2. Now, you don't have to write all this down. Just write, oh, yeah, not example 2. What are we on now? 4? Okay. There we go. Now, you don't have to write all that down. Just give a basic summary. Since opening day, attendance at Pool A has increased steadily, while attendance at Pool B, it rose and then it fell. Isn't that kind of like a quadratic? Rising and then falling if it's quadratic with concave down. Equations modeling the daily attendance Y at the pool. So what does Y represent? Daily attendance. So that would be something important to write down. Daily attendance is Y at each pool are shown, where X represents what? Keep reading. X is the number of days since opening day. So those would be two things to write down. On what days was the attendance the same at both pools, and what was the attendance? So there are two questions. You should write down the questions. On what day was the attendance the same, and what was the attendance? Okay, without a calculator, what does it mean when they are the same? If we graph both of these, what will we be looking for? They're intersect. When they're intersecting, they are exactly the same. Okay? But we're not going to graph them on our calculator. We're going to do this a different way. So no touching your calculators. Hands off the calculators. And then we're going to find what was the attendance. Which variable represents the attendance? The Y. So if we had a graph, I'm just going to draw a random graph, something like this. Say that's where we are looking for. X is number of days. Y is attendance. So what are we looking at on the intersection point for attendance? We're looking at how high that point is. So we would find the Y value. Okay, but we're going to do this a different way than by graphing it this time. This is by elimination. So make sure you have your two equations written down. The setup is to line them up vertically. First step, line them up. So I want to make sure all my like terms are lined up. The longer function is at the bottom, so I'm going to write that one first. And then I want to make sure pool A's terms are lined up with their like terms. Where should I put 28x? Yeah, above the 39x, so that they're like terms. Where should I put the 4? Yeah, probably, right? Okay, now we're going to condense it to one equation instead of having two. We do that by subtracting. Subtract. Like terms, but we're subtracting all of this. So I'll put that in big parentheses, we're subtracting all of it. On each column, y minus y would be
Nothing.
0. Now careful here. 0, right, because there's nothing there. 0 x squared minus a negative x squared. What does that do when we minus a negative x squared? It'd be positive x squared, right? Minusing a negative makes a positive. Minusing a negative makes positive. Now we're minusing a 39. So if it helps you, you could go through and change all these. This would now be plus. This would now be negative. This would now be negative. So and this was negative if you distribute that in. Okay, so 28 minus 39 on the x's is negative, what's 28 minus 39? Negative 11x. And lastly, 4 minus 64. Negative 60. We should know how to solve, it's one equation now set equal to 0. How do we solve a quadratic that's equal to 0? Yay, you guys know. Factor. Okay, two numbers that multiply to negative 60 and add to negative 11. You can do the x if you need to and do a list. Two numbers that multiply to negative 60 and add to negative 11. Think about it. Do a list if you need to. I think 5 and 6 multiply to positive 60 and add to positive 11. Oh, that's true. And they multiply to positive 30 and add to positive 11. Okay? 15 and 4? Negative 15, positive 4. Does that add to negative 11? Good. Good work, Bryson. So x minus 15 and x plus 4. But those are not solutions. Those are factors. Okay, I need someone on this side. If I have factors, how do I find the solutions? Not the Xbox. Xbox is to finish the factoring, which we've already done. This is, how do we find X? We do a little squiggly line. And set each individual factor equal to 0. This is using the 0 property. So apply the 0 property to solve. Set each factor, not equation, factor equal to 0. So this one ends up being x equals, Christine, what will x be here? What number minus 15 equals 0? Okay, so if you need help, we can do the inverse. So it'll be, yeah, so it's just the opposite sign. If there's a negative 15, we would write positive 15. That would be 0. So Christine, what about this one? It's positive 4, so there'll be negative 4. There you go. Those are the two places where the graph will cross. Those are the x coordinates. But we need a point. What? It's the same idea as the axis of symmetry. If you have the x, how do you get the y? Plug it in, plug it in. Because it's the song. Plug it in, plug it in. That song. Plug it in. Okay? Where do we plug it in? Actually, if you plug it into both, you get the same exact answer. So you only have to do it once and do it to the easier one. Which one's easier at the beginning?
The top one.
The top one looks way easier. So y equals 28x plus 4. Y equals 28x plus 4. We're going to replace the x. We have to do this twice. Once with the 15 and once with the negative 4. Okay, type both those in. Let's see. Okay, on the first one. And on the second one. So our 2 points would be 15 comma 424 and negative 4 comma negative 108.
Why not axis of symmetry?
Because we're not looking for the vertex. That's when you're looking for the vertex. Okay. Next method is using substitution, which is actually what we just did. When we plugged it in, we were substituting in. So, next problem, example 5. What are the solutions? Meaning, where do these two functions intersect? Solving by substitution is you're going to plug in one equation into the other equation. EQ is what I'm using for equation. And it's really nice if they already solved for a variable. See how this guy is already solved for y?
Oh, I do.
Oh, good. So y equals 4 minus x. So what does this y equal if we're looking for where they're crossing? 4 minus x. So I'm going to replace this y with 4 minus x, but it still equals everything that was on its right side. X squared minus 6x plus 10. Or essentially, if they're both already equal to y, You just take both equations, drop the y, and set them equal to each other. Okay, I'm going to fix my 10 here. That's not very clean. Okay. Now how would we solve for x? Find your like terms. Can we have them when they're both on different sides? Nope. We need to get them all to one side. Making fun of me, Caesar? We need to get them to one side, and we want x squared to be positive. So I'm going to choose to move it to the right because x squared is already positive. So I'm going to subtract 4 and add x, both sides. Make sure I do them with their like term. I'm going to put the subtract 4 with the 10, because those are like terms. And I'm going to put the add x with the negative 6x, because those are like terms. So I did it in one step. Are we okay with me doing both those steps in the same line? Does anyone have a question on what I just did? Make sure your x's are lined up. Make sure your constants are lined up. So the left side is 0 equals.
X squared minus 5x.
Whoa, okay. X squared minus 5x. What's the rest, Waji?
0.
Mm-mm.
Oh, hold on. 6.
Plus 6. And now it's just like the last problem we did. What's the next step?
Factorization.
Factor. 0 equals 2 numbers that multiply to 6.
2 and 3.
Nope. I'm going to call on someone for this one, please. And add to negative 5. Don't shout it out. Think about it first. 2 numbers that multiply to 6. Ryan, sit up, please. And add to negative 5. Okay, Andres, can you give me 2 numbers that multiply to 6 and add to negative 5? Negative 2 and negative 3, would that work? It sure will. Good job. So, x minus 2 and x minus 3. Those are the factors, though. They're not the solutions. Okay? Brian, is it P? Okay, I was confused for a minute. Brian P, how do we find solutions if we know the factors? Zero property. So it means we set each individual factor equal to 0. So apply the 0 property to find x, or to solve for x. Which means, I like to do a little squiggly. X minus 2 equals to 0, and x minus 3 equals to 0. Okay, Davis, what are our 2x values here? Yep, good. Okay, those are the x solutions, but we want points. So after we apply and we find the x's, how do we know the point?
Plug in the x.
Okay, yeah, I almost thought you were going to sing for us, Bryson. Plug it in, right? Plug in the x to find y. Now, you can plug it into either one of the equations. Is there an easier equation that looks a little less complicated?
4 minus x.
Yeah, that one at the bottom. So y equals 4 minus x. I'm going to use that guy. And my x is now going to be 2. 4 minus 2 is 2. So that point is 2, 2. We plugged in 2 and we got 2. And then last one, 4 minus 3 equals 1. So our point is, we plugged in 3 and we got 1. Those are the solutions. Cool? The very last thing I'm going to show you is another graphing with the calculator. Actually, no, it's the same thing we've already done, and we did 3 of those, so I think we're okay. Do you need any other examples of one of the last 2?
No way.
Okay, then let me tell you what your homework is. This part's in the book. And when we go to the computer lab, if you've already done your completing the square, you can work on this book assignment. But if you haven't, you can continue working on completing the square. Page 211, numbers 1 through 12, and 16 through 20.
Whoa.
What's not?
Look at that.